Hey everybody, Mr. Regan here, and today we are going to be starting part 2 of our egg drop experiment, where you're going to be constructing, testing, and then creating a final model needed for your egg drop pod. Now that we have brainstormed and modeled how we will be building our egg pod, it's time we can constructing our pod while thinking about minimizing costs. So, mechanical engineers have to take into consideration the cost of materials to ensure that they have what they need to accomplish their goals and don't run out of the materials needed to be successful. Because of this, mechanical engineers have to select only the most important materials they can use without being wasteful, so not having excess materials and things they don't need, or losing out on important materials because they don't have enough money. Remember, their goal is to solve the problem, and minimizing costs is a part of that equation. So, mechanical engineers start their building process by thinking about the cost of materials that will help them best meet their design goals. So, how can I spend money on these materials that I need to meet these goals? Your design goals for this egg drop pod is to minimize the damage to the egg. We know that by using materials you purchase within a specific budget. So you are going to be given a certain amount of money to use, and you need to stay within that budget, meaning you cannot spend more. You can spend less, but you cannot spend more. The materials you purchase must help you do three things. Number one, you have to increase the collision time. Remember, the longer it takes for that object to collide, the better. So the longer it takes for that egg to hit the ground, the more likely you will have a successful pod. You need to minimize collision force. So you need to minimize how hard or how much force is used when that egg hits the ground. And last but not least, you need to stay under budget. You are going to be given $60 to spend on materials. Okay. So let's see how you're going to buy materials within that budget. So you are going to be given a pod building material order form. Okay. It's going to look like this. All right. Now, the material that we see here are just a snapshot of what you need. Okay. So, or what you have available to you. So, for example, there are only maybe 8 to 10 items here. You're going to have closer to like 15 to 20. You'll see the materials are here. You'll see the amount, the maximum amount that you're allowed to use in order. You'll see the individual cost. Okay. And then in the last two columns, you are going to tell me how much you need of those items, what the cost is going to be, and then there's going to be a total at the bottom. So, for example, if you wanted to purchase a pillow, you can get a maximum of 2 pillows. They are $30 each. So let's say you only want one pillow. Well, one pillow for $30 is, $35 is going to be 35. Now, if you wanted two, that would be 70. You couldn't do that. That would be over your $60 budget. Okay. So you have to stay within budget. Toothpicks. Let's say you wanted toothpicks. You can get maximum 20. Now, they are $1 for 5, meaning if I wanted 10, okay, $1 for 5, that means I got $2 worth of toothpicks. Now, do I need to order all 20? No, but that's the max. Next, let's say I wanted masking tape. You can have up to 4 feet. They are $5 each. So let's say you wanted all 4 feet, then that means you have $5 per foot. So 5 times 4 is $20. So if I add this all up, I got 35 plus 2 plus 20. That makes $57. I'm within my $60 credit limit. So now I can take all those materials and I can build my model. Now, whatever you decide to use, it can be different from your original idea. That's okay. That's a part of how a mechanical engineer takes cost into account. So if you had a laundry list of things you wanted to use, but now your budget only allows you to use a portion of it, that's okay. What that means is you're going to go back into your modeling tool and you're going to change what your original idea is. So if I had an original idea that had me building a plane around my egg, Now I'm going to get rid of that, and I'm going to pull in the things that I use. So I have my pillow. Let's say I wanted to use my toothpicks, and I wanted to put them underneath. And then I was going to use some tape to put those on. And then I was going to use more tape to get the egg on top of the pillow. And now I'm going to have to label everything. So obviously there's my pillows there. Let's see. There's my toothpicks right there. And then my tape. I probably need a few arrows, but that would be my tape. So now I have my new model. Okay. So once you build and create your final model for how it would look, you're then going to go in and you're going to begin testing whatever you build. So once you build, for example, what we have here, putting the tape and the pillows and the toothpicks together, you're going to come into the next task and you're going to do a practice drop. Okay. So you're going to build and drop your egg pod from the height of the tallest person. So if I'm the tallest person in my group, I'm going to hold it at my tallest point and I'm going to drop it. Okay. But we're going to give you a fake egg so that you can practice what we're doing for our egg drop. So you can practice calculating what happens in the lab and so that you can make any final adjustments. So in order to figure out if our egg was successful, we're going to collect some data. The first thing you're going to need is the mass. Okay. The mass of your egg. So that's going to go in the mass column. So you're going to use a scale to measure the mass of your pod. Next, everyone's a little bit different in height. So you're going to measure the distance the egg falls. So I'm going to measure with a measuring stick how tall I am. And that's going to go in the distance because that's how far it's going to drop. You're going to measure the time it takes. So from the time that I drop it to the time that it hits, I'm going to use a timer and I'm going to start and stop it. I'm then going to measure the speed of my pod. So I'm going to need a calculator for that. Speed is going to be the distance it travels divided by time. So if I'm 60 inches tall and it takes 2 seconds to drop, 60 divided by 2 is going to be 30 inches per second. So it's traveling 30 inches every second. I'm then going to calculate the impact force or the maximum impact force. So how much force was applied to my pod. To do that, I'm going to take the mass of my object, okay, which my mass was 5 grams for my pod, let's say, and I'm going to multiply it by the speed at which objects drop on Earth. So objects drop on Earth by 9.8 meters per second squared. So 5 times 9.8 is 49 newtons. That's how much force would be applied if my object were to hit the ground. And then last but not least, in the final column, I'm going to record any notes or changes after we make observations. Do I need to move some things around? Do I need to adjust how things are taped or tied or whatever? Do I need to change where in my pod my egg is? So every time we drop it, we're going to record those things, make some changes, and then do it again. And then do it again. 3 practices to get your best pod with a fake egg. So, take a second, folks. Ask yourself, do you understand how to use the material order form? Do you understand how to complete the next 2 tasks where you revise your model, so change what you're doing, and test your pod design? Take a second, place your X where you fall. If you put your X in yellow or red, reach out for help. Otherwise, good luck.